Good morning, guys. Here is your review session for your trig midterm. Like I said in my email, I do not have my document camera with me, so I am unable to go step by step with the problems in front on the camera, but I will make sure I write the problem down every time. Just follow along. We're going to start at number 1, and this video is just going to keep on going until we're done. So, thank you in advance for your time and patience. We're going to start with number 1, letter A. It says draw the following angles in standard position, and the angle that we are looking at is negative 7 pi over 3. Now, I believe we talked about this one in class, but just to refresh your memory, remember the whole way around the unit circle is 2 pi. 2 pi, if you would give it the same denominator as this, ends up being 6 pi over 3. So, as you go all the way around the circle this way, it's 6 pi over 3. But we don't want positive. We end up wanting negative. So instead of going counterclockwise, we need to go clockwise. And all the way around the unit circle this way is negative 6 pi over 3. So from here, this way is negative 6 pi over 3 when we make it all the way around. But we're not all the way to 7 pi over 3, so we need to take it 1 pi over 3 more this way until we hit 7 pi over 3. Now 1 pi over 3 this way is the same as looking at the 5 pi over 3 angle. So when it says draw the following angles in standard position, the angle that we're looking at is this guy right here. This degree would be 60 degrees. And once again, we went negative, so we actually went clockwise instead of counterclockwise. And that's how you end up coming up with the angle for this. Now, moving on to part B, it says we want to find the angle for 510 degrees. Once again, all the way around the unit circle, if we started here, is 360 degrees. We need to go 510, so 510 degrees minus 360 degrees ends up being 150 degrees. So we need to go an extra 150 degrees. If you look at your unit circle, it ends up, how do I do that? Looking like this. Right here is 150 degrees. Our radians is 5 pi over 6, just from here to here. Now if you went all the way around and then kept going, you would add 2 pi to that. But anyway, our angle looks like this. And that is 510 degrees. Well, that's part 1. Hopefully they're all this easy, right? So the next thing we need to do is number 2. We want to convert 19 pi over 18 to degrees. Now to convert this, we need to take this 19 pi over 18 and we need to multiply it by 180 over pi. This will always take it from radians into degrees. Now if you look, the pi on the top and on the bottom cancel. 18 and 180, this becomes 1, this becomes 10. So now we have 19 times 10, which is 190 degrees. And that's how you convert 19 pi over 18 to degrees. Hey, guess what? We're done with number 2. Number 3 is a little bit trickier, it says we want to find the arc length cut out by a central angle of 150 degrees. So here's 150 degrees with a radius of 9 feet. Now there are two different ways that we can do this. I'm going to split this screen in half. I'm going to do number 1 here and number 2 there. The first way you can do this is you know that the circumference is 2 pi r. That's the formula for circumference. It's also the same as pi d, pi times the diameter. Well, the radius is 9 feet, so 2 pi r, 2 times pi times the radius, that's going to be 18 pi, which is the same as pi times the diameter. So we have 18 pi. Okay, that's the circumference. But the circumference is 360 degrees. We're only wanting 150 of that 360. So we're doing 150 over 360, using the proportion, times 18 pi. Okay, when we simplify this, 360 and 18, this ends up being 20, and this ends up being 1. Those zeros cancel, so we have 15 over 2 pi. So 15 over 2 pi. And if you would end up using your calculator, that ends up roughly being, I have to use 3.14 because I didn't bring one of the scientific calculators home with me. That ends up being roughly 23.55 feet. Now, to do it the second way, we just set it up as a proportion, once again. And with this proportion, we end up saying we have 150 degrees out of the 360. Our radians is 2 pi, so we're going to multiply by 2 pi, and then we're going to multiply by the radius, which is 9. Now, in simplifying this out, these zeros cancel, leaving us with 15 over 36. 36 and 9, this becomes 4, this becomes 1. We have 4 and 2, so this becomes 2, this becomes 1, leaving us with 15 over 2 pi, which is exactly what we had here, which ends up giving us 23.55 feet. So far, keep saying ladies and gentlemen, but in this class we only have ladies. So ladies, I hope that this is okay. That's the end of problem number 3. And now we are on to problem number 4. And it says, given the point 4, negative 5, so if here's 0, 0, okay, here's the terminal side. And we're given the point 4, negative 5, so we're going to go this way 4, and we're going to go down 5. So this point right here. It says, given this point 4, negative 5, as a point on the terminal side of angle theta in standard position, give the 6 trig functions of theta. So, once again, this angle right here is theta because this is where our central angle is. Okay? So, what we end up needing to do is we need to find the hypotenuse, and then from there come up with the 6 trig functions. So, sine of theta, cosine of theta, tan theta, cosecant of theta, secant of theta, and cotangent of theta. Don't forget, secant, cosecant, and cotangent are their counterparts just flipped over. Okay, so first we need to find this x. So easiest way of doing this is a squared plus b squared equals c squared. So 5 squared plus 4 squared equals x squared. So this is 25 plus 16 is x squared. 25 and 16 ends up being 41 is x squared. So we have the square root of 41. I don't have a calculator that can do that, so I'm just going to leave it the square root of 41. Okay? And this actually keeps it exact, and this is something that I actually would hope that you guys would be able to do as well. So sine theta is sine, so it's opposite over hypotenuse. So this ends up being negative 5 over the square root of 41. Now, we can't have a square root on the bottom, so we have to multiply top and bottom by a square root of 41. So this ends up being negative 5 times the square root of 41. Square root of 41 times the square root of 41 is just 41. So this square root actually goes away. So now we have just negative 5 times the square root of 41 over 41. And there's your answer for sine. Cosine is equally as difficult or easy, however you view it. We do adjacent over hypotenuse, so this is 4 over the square root of 41, which when we multiply top and bottom by the square root of 41, this gives us 4 square root of 41 all over 41. Okay, 41 is a prime number, so we are unable to simplify those out. Tangent is a whole lot easier because it's just opposite over adjacent, so that gives us negative 5 over 4. Cosecant is the opposite of sine. If we flipped it how it was, we'd have the square root of 41 on the bottom, and we would have to get rid of that from that square root on the bottom. So instead, I'm just going to remember back, and I remember that it was negative 5 over the square root of 41, so I'm just going to flip that and say we have the square root of 41 over negative 5, and that negative pulls out front. Secant is the same thing, so we have the square root of 41 over 4, and cotangent is negative 4/5 because that's the flip of the tangent, which is negative 5/4. Okay, so there is number 4. Number 5, that was number 5. Or no, that was number 4. Now we need to find number 5. It says, suppose sine of theta is negative 4 over 7. So we know that sine theta is negative 4 over 7. That means that either our opposite or our hypotenuse is negative. Okay, but we're told that tangent theta is greater than 0. Now, if tangent theta is greater than 0, we have two options there. It's either going to be opposite and adjacent is positive, or opposite and adjacent is negative. Okay? So with tangent being greater than 0, that means we're going to have a positive slope. That means we have one of two ways that we can draw our triangles. One is this way, with theta being here. One is this way, with theta being here. Now we have sine of theta being negative 4 over 7. Okay? Our hypotenuse is running positive. So that means our opposite side has to be going negative. Well, this one is going up, that's positive. This one's going down, so that's negative. We need to use this triangle. So, here's theta. We know that the hypotenuse is 7. This is 4. We need to figure out this guy. So, I'm going to erase most of this. So we end up having 4 squared plus, now this is x squared because this is our other side, equals 7 squared because that's our hypotenuse. So 16 plus x squared equals 49. Subtract 16. So x squared ends up being 33. Take the square root. That doesn't go cleanly. So the x is the square root of 33. So we have sine. Now we need to find cosine, tangent, secant, cosecant, and cotangent, all using that negative 33, and I did not want to erase that. I'll redraw that. So this was square root of 33. And actually, since it's running this way, that's a negative. Okay, this is negative 4. This is positive 7. Okay, so cosine of theta is, there's theta, is this negative square root of 33 over 7. And hey, the square root's on the top. Don't have to worry about a thing. Tangent of theta is opposite over adjacent. So that's negative 4 over negative square root of 33. Well, first off, these negatives cancel to be a positive. Second, we have to get rid of that square root of 33, so we multiply the top and bottom. That gives us 4 square root of 33 over 33. And there is tangent theta. Okay? Cosecant of theta ends up being sine flipped, so that's negative 7 over 4. Cosine theta flipped is secant theta, and that ends up being 7 over square root of 33. Once again, negative. Can't have the square root on the bottom, so we flip it to the top. So 7 square root of 33 over 33. Okay? Now, tangent theta was originally this. Flip that over, that's the square root of 33 over 4, and that is cotangent of theta. And by golly, we have number 5 done. 6 is a lot more trickier because we now have to graph. Okay, we want to graph y equals 3 cosine of 2x plus pi over 2. Okay, we need to show at least one period, and we need to label several points. So, we're going to do cosine, so we know it's going to start up at the top, go down, then back up, and that'll be one period. Okay, now that 3 in front means that this is a negative 3, and this is a positive 3. Okay, don't forget, the formula ends up being a cosine of wx minus phi. Okay? And this also, and so therefore, we know a is our 3 and negative 3. We already got that guy. Okay, next is our w. Our w ends up giving us our period. Okay, typically it's 2 pi, so it's 2 pi over w, so 2 pi over 2 ends up being pi, so we know our period is pi. Okay, now how we shift this is a little bit different. Okay, how we shift this is phi over w. Okay, so we are going to shift this pi over 2 over 2. Okay, now this pi over 2 over 2, this right here becomes 1, so we are actually shifting it pi units to the right. Okay, so here is pi. This is where we're starting up here, coming down, and then back up. Our period is pi, so 1 pi added onto this guy ends up being 2 pi right here. Okay, so this is pi, this is 2 pi, this would be 3 pi over 2, because it is halfway in between there. Halfway between here, this part right here ends up being 3 pi over 4. And this right here ends up being between 3 pi over 2 and 2 pi. That is a pi over 2 difference, pi over 4, so 6 pi over 4. So this ends up being 7 pi over 4 right here. On this point right here. And, bada bing, bada boom, we have it graphed. Okay, so the next problem, number 7, it says find cotangent of sine inverse of negative a half without a calculator. Give an exact answer. This is where the chapter 7.1 tables come into play. Cotangent is the same as 1 over tangent of sine inverse of negative 1/2. Well, sine inverse of negative 1/2 ends up being negative pi over 6, so we have 1 over tangent of negative pi over 6. And actually, remember, tangent is sine over cosine. Cotangent is cosine over sine. So instead of even flipping this around, we can do cotangent of negative pi over 6, which gives us cosine of negative pi over 6 over sine of negative pi over 6. So cosine of negative pi over 6 over sine of negative pi over 6. Okay? Now, with this, we have to look at our unit circle. And in our unit circle, cosine of pi over 6 is square root of 3 over 2. But since it's negative, it's going to be negative square root of 3 over 2. Over, now sine of pi over 6 is 1/2. So sine of negative pi over 6 is actually negative 1/2. And I was wrong about the cosine. It is positive because instead of going our unit circle from here to here, we are pi over 6. We are now going here to here pi over 6 because this is negative. Okay, this point right here, the y is negative and the cosine and the x is positive. Remember, cosine is x, sine is y, so that's why this guy's positive, this guy is negative. Okay, so we have positive square root of 3 over 2 over negative 1/2. Negative over positive is a negative, so we know this is going to be a negative. When we divide by a half, that's the same as getting rid of this and multiplying this by 2 over 1. It's reciprocal. That cancels out, so we have square root of 3 over 1, which is just square root of 3. So the answer would be negative square root of 3. And there is number 7. Okay. Number 8, we say we want to graph y equals CSCX. So y equals CSCX, that's cosecant. That's the same as 1 over sine x. And just so you know, this would be the easiest to graph using a graphing calculator. Plug this into your graphing calculator. You will set your, if you look at the graph underneath, you would set your left bound as, so left bound is negative 5 pi over 2. Right bound is 5 pi over 2. Your upper bound, your y max, the left bound is also your y min, or your x min, I should say. Not x min, x min. And this would be your x max. Your y max would be 2. Y min would be equal to negative 2. And then I would say that your steps for x would be pi over 2. And for your y, the step would be 1 for steps. That's step for y. This would step for x right here, pi over 2. And that'll graph it once again. I do not have my graphing calculator. If you have any questions, I will answer it right before the midterm on Monday. I'm planning on letting you have 5 minutes to ask any questions, anything that was confusing from this. And we'll just take each of those as they come. Now the next two we have to solve. This is number 9. The first one is 2 sine theta is equal to negative 1. I divide by 2, so we have sine theta equaling negative 1/2. I want to get theta by itself, so I do sine inverse. Cancels, so theta equals sine inverse of negative 1/2. We look at our chart. Sine inverse of negative 1/2 ends up being negative pi over 6. Okay, so there is part A. Part B is a slightly trickier one. You have 2 sine squared theta plus sine theta minus 1 equals negative 1. Now the first thing I want to do is I want to move this negative 1 from the left to the right, okay, this way. Now negative 1 plus 1, it gives us 0, so we have 2 sine squared theta plus sine theta equals 0 because these canceled out and these canceled out. Okay? Now these have a sine theta in common, so I can say sine theta times 2 sine theta because I pulled 1 sine theta out of this guy right here. So we have 1 left over. I pulled a sine theta out of this guy right here. That just leaves us with a plus 1 equals 0. Okay, so now we're going to have 2 answers. We're going to have this sine theta equaling 0 and 2 sine theta plus 1 equaling 0. So 2. Okay, now once again, with this guy, this will be easy. So theta is equal to sine inverse of 0, sine inverse of 0. So theta is 0. That's one of our answers. The second one, so we've got that one taken care of, so theta equals 0. The second one we want to look at is we want to look at this guy right here. This is equal to 0, subtract 1, subtract 1. So 2 sine theta is equal to negative 1, divide by 2. So sine theta is equal to negative 1/2. So theta is equal to sine inverse of negative 1/2, which we just figured out is negative pi over 6. So theta is equal to negative pi over 6, and theta equals 0. There are your 2 answers. Okay? And there we are done with number 9. Okay, for number 10, part A, we want to prove the following trig identities. And we're given that cosine theta plus tan theta sine theta is equal to secant theta. Okay? Now, we know secant is the same as 1 over cosine, so 1 over cosine theta. Tangent is sine theta over cosine theta, so this is times sine theta. So plus cosine theta. Okay, sine times sine is sine squared. So we have this cosine theta plus sine squared theta over cosine theta equals 1 over cosine theta. Now I don't know about you, but I personally do not like fractions, so I'm going to multiply, since I have cosine theta, I'm going to multiply by cosine theta on both the left side and the right side to absolutely everything. So cosine theta times cosine theta here, cosine theta times sine squared theta over cosine theta, and cosine theta times 1 over cosine theta. Cosine theta times cosine theta is cosine squared theta, plus this cosine and cosine cancel, leaving us with sine squared theta, equaling, now 1 over cosine theta times cosine theta, those cancel out, leaving us with just 1, and bada bing bada boom, guess what? We know that cosine squared theta plus sine squared theta equals 1, therefore proving that this guy way up here is also an identity. So this next example, guys, just heads up. I'm not clearing my throat because I've got something stuck in it, just so you know. is very important. So this next one is sine parenthesis alpha plus beta over sine alpha sine beta equals cotangent alpha plus cotangent beta. Okay? Now from here, I want to go ahead and switch the cotangents to be cosine over sine. So we have this sine alpha plus beta over sine alpha sine beta equals cosine alpha over sine alpha plus cosine beta over sine beta. Okay? So then after that, what we end up needing to do is I want to get rid of this denominator right here. So I multiply it to everything. So sine alpha sine beta to here, here, and here. Now it cancels this one out completely, leaving us with sine of this alpha plus beta. Now this equals this sine alpha and this sine alpha cancel, leaving us with cosine alpha sine beta, plus this sine beta and this guy cancel, leaving us with sine alpha cosine beta. And the interesting thing about this is actually a sum and distance formula. Okay, found on page 498 in your book, where it says chapter review, things to know. Under sum and distance formula, the second one down, it says sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta, which is this guy plus this guy. So, even if you flip these around, you end up with an identity that we know, so therefore, this proves that this guy in blue is actually an identity. Guys, this next one is looks really bad, but I promise you it takes like 2 steps and it's done. Also, just so you know, I will provide you with from chapter 7 identities. I will provide them for you. Oh, you don't have to waste them on your paper. So anyway, we need to prove this guy. Now, cotangent here, that is once again cosine over sine. So we have this cosine of 2 alpha over sine alpha equals cosine alpha over sine alpha times cosine alpha minus sine alpha. Okay. Next thing I want to do is I want to multiply everything by sine alpha. So sine alpha, sine alpha, sine alpha. Okay. This guy and this guy cancel. This guy and this guy cancel. So we end up with cosine of 2 alpha equals cosine alpha times cosine alpha is cosine squared alpha minus sine alpha and sine alpha is sine squared alpha. That's theta, I want alpha. And guys, just so you know, once again, back on page 498, where we have sum and difference formulas, we actually have a formula that says this guy. So, therefore, this works. Thus, you're done. Easy enough. Yay. And guys, we are almost done with this video. We have one more really tough one, and after that, it seems like it's smooth sailing from here. So number 12, it says, without a calculator, find the following. This is kind of difficult because we have tangent of 22.5 degrees. Now guys, tangent 45 is 1. So we know tangent 45 is 1. 22.5 is half of that. So half of 1 is 1/2. Bada bing, bada boom. There it is. Okay. Now, guys, letter B, we have cotangent of 15 degrees. Okay. Now, cotangent is the same as 1 over tan 15. Now, guys, don't forget, tangent is sine over cosine. So cotangent is cosine over sine. So I'm not even going to worry about this guy. This is going to be cosine of 15 over sine of 15. Okay? Now, cosine of 15 is half of cosine of 30. Cosine of 30 is square root of 3 over 2, so that's half of square root of 3 over 2, which is square root of 3 over 4, over sine of 30 is pi over 2, so sine of 15, half of that is 1 over 4. So half of a half is a fourth. Fraction over a fraction, that means we multiply by the reciprocal, so multiply by 4 over 1, that gets rid of him, cancels that, this equals the square root of 3. And we're done with number 12. Number 13 I'm not even going to bother with because you can punch it in the calculator. Now don't forget, look at A. A says sine of 61. That's in degrees. B is secant of pi over 2. That's in radians. So you're going to have to make sure you switch your calculator. For A, you're going to have to make sure you hit mode, change it to degrees. For letter B and letter C, you're going to have to make sure you hit mode and change it back to radians. Alright, so for number 14, it says choose the best answer to the following multiple choice questions. It says tangent theta is less than 0 for theta in what quadrant? Well, this actually has two answers. Okay? Theta, or tangent theta, is less than 0 in the second and fourth quadrant, because if you remember on our first one, when we were first talking about this, we had tangent theta being greater than 0. Now it's less than 0, and instead of it being in quadrant 1 and 3 for if it's greater than 0, it's in quadrants 2 and 4 if it's less than 0. Okay, number 15. Cosecant of 5 pi over 6. So, cosecant of 5 pi over 6, that's 1 over sine of 5 pi over 6. If we look at the unit circle, 5 pi over 6 is 1/2. So this is the same as 1 over 1/2. And actually, yeah, it's a positive 1/2. This equals 2. Okay, 16. Use your calculator, approximate cotangent of 78 degrees. That means you're going to do 1 divided by tangent 78 degrees and tell me what that is. 17, use your calculator to find that cosine of pi over 8 is approximately what? You're going to just punch in cosine of pi over 8. Make sure it's in radians, because we're dealing with radians. 16, you're going to have to make sure it's in degrees. Otherwise, you'll get them wrong. And 18, use your calculator to find sine inverse of negative 0.85 is what? Okay, there's no degree mark there. That means it's in radians. So you're going to do second sine of negative 0.85 as it is in radians, and you get your answer. Ladies, guess what? Under 40 minutes, and we were able to get through all of them. So, once again, I will leave about 5 minutes before I give you the midterm to ask any questions that you might have. And don't forget, you're allowed 1 full sheet of paper, front-sided only. Have a wonderful weekend. Bye.